everyone, welcome to Docker in Practice. This is the fifth of the videos about Docker. In the previous lesson, we talked about rate limiting and we showed how we can use Nginx rate limiting to prevent DDoS attacks. And we showed that we applied this rate limiting to our login API. And as you can see, we restricted only 2 requests per minute to the login API, and more than 2 requests are blocked by the Nginx through rate limit feature. In this lesson, I'm going to talk about database. We know that almost every web application requires a database. A database could be a file, SQL, NoSQL, or a cache, memory caching. And it's imperative to create a database server and manage the connections to the server, to the database servers, only because of the efficiency purposes. And we use connection pools. Sometimes we use connection pools to manage the connections, and also managing dependencies. For example, when you want to orchestrate so many numerous amount of application in the Docker, it's important to manage dependencies and by using some initialization scripts for your database. Let's deep dive into the demo. In the Docker Compose file, I have created a service called DB. It is a PostgreSQL database, and then I have created the image locally through the Postgres.Dockerfile. Let's see how it looks like. I use the PostgreSQL base image, and I have created initialization script and put it under Docker entry point init.db directory. So any script that is under this directory, just at the beginning of initialization, only once, it will execute it only once. In this file, I just do 3 things. I create a user with a password, I create a database, and I grant the permissions on this database to the user. So I use this user and database in my future services if I want. So if you want to create other databases, so you can create as many users and databases in this initialization script. So let's create this image first. Through Docker Compose build command, we can create this database image. It will create this image for us. PostgreSQL local. First, I will kill all already running services. I see that it was running before because I wanted to test something, but now I killed all the services. Let's see how many services are running. So not it's running. I created just image now, and then I use Docker Compose to bring up the service. This will bring up the Docker Compose service for us. And make sure that the script is run, the initialization script is run, and then the database and the users are created. Let's see, and we see that database is healthy. So how we know that it's healthy? What I did is that in the Docker file, I have created a health check command. It's important that you add this health command to every one of your services. It could be in the Docker file like here, or it could be in a service. Like in the web server, I have created in the Docker Compose service. You can put in either place. And the command to make sure that if PG or Postgres is healthy is this command. Now we see that database is healthy. Now let's see how the auth service is using this database. So we have a service which depends on a database. This auth service is used for user authentication or creating or signing up an account. We know that everything starts from main.py file. In this file, I have created a function called setup.db. This will set up the database for us. What it does, is that first it initializes the connection pool to the PostgreSQL database. In this function, it creates a DB pool for us, and the number of connections is managed by min size and max size, which is usually 1 to 7. In the settings, we see that it's minimum 1 and maximum 10. Let's see to set up that DB. And then once the connection pool is created, we create all the tables that we want. We use SQL Alchemy metadata feature here, and all the tables we have in the auth.models. If we go inside metadata, we see that there is auth tables created with all the required columns, including ID, first name, last name, and all other fields. So once the DB setup is finished, we can use this database connection for our API. In our case, I have created a sign-up method. This sign-up is used for creating users. Whenever this API is called, which is API v1 sign-up, it will create a user in the database for us. In this function, it makes use of the DB connection pool and then uses the helper class to create or insert a user to the database. Let's see how it works in the Postman. Probably I had created this before, but I created a new user called test2 with all the required fields here. Let's see if it works. No, because none of them are up. As you see, I have to bring up the services. But before that, I want to show you how you can manage dependencies. So I want to bring up auth service, and also I have a web server here. And in the web server dependencies, I mentioned that the web server depends on auth. So before bringing up the web server, it makes sure that auth is also up and it's also healthy based on the condition of service health. So once I want to bring up web server, it makes sure that auth there is also up. It's a great way to managing dependencies in Docker. In case, for example, when you have so many services, adding this dependency would be a great help. Let's wait until auth service comes up. Probably it takes 1 minute because the interval is 1 minute, but you can customize these values. Yes, auth is up, and then web server came up. So let's make a request to the sign up with the username test2. Let's see if it happens. Oh, we see that the email already exists. Let's make it test2. And it created a user for us with this email and with this password on the state. So it showed that the database connection works. Now let's see if we can get this user information test2, and we can get this user information. Hope you have learned something today. Let's review what we talked about today. So we talked about database, how you can create a database for your services, how you can manage dependencies of the services to the DB through depends on directive in the Docker Compose, and how you can use health check to make sure that the services are all healthy. For example, here we see that all 3 services are healthy. For web server, it takes some time. Hope you have learned something good today, and in the future we will talk about caching, specifically in the application layer, and a few more topics that we'll cover in the future. Thank you for watching and have a great day.